Welcome to Dampere Chemtech. Now I'll be making a video this time around on scientific measurements. Now, in the world of science or in the science laboratory, measurement is very, very important. It's very essential. Because in the laboratory, whatever you do is either you are making measurements of length, mass, time, concentration. It can be current, temperature, and what have you. Other measurable quantities are measured in the laboratory. So a student must be well acquainted with measurements. When we say measurement is equals to a numerical value plus units. A report cannot be called a measurement when there is no units. For instance, an object is given to a student to take measurements of the mass, and the student returns and say the weight of that object, or the mass of that object rather, is 5. It does not make sense at all. The question the teacher or the audience will be asking, is it 5 grams? Are you talking about 5 milligrams being mass? Are you talking about 5 micrograms? What are you talking about? Until the student comes with a report that the weight of the object or the mass of the object is 5 grams. Then 5 there is the numerical value, while the gram is the unit. Then that measurement makes sense. So it can be accepted as measurement for that object. So students should take notes. In any measurement you are making in the lab, there should be the appropriate units. You report it with the appropriate unit of that measurement. Now, when we talk about measurements, now, when a number represents a measured quantity, the unit of that measurement or that measured quantity must be specified. Must be specified. That is when measurement makes sense. The units used for scientific measurements are called metric system of measurement. The metric system. And the metric system was actually developed in the late 18th century at France, where you have prefixes and symbols to represent measurements. Is what metric system is all about. In the 1960s, a body of scientists comes together and agreed on what we call System International Units, where from the metric system they decided or agreed that certain measurable quantities should be represented with certain units and symbols. And that is what we call the SI units. For instance, we have length, mass, time, amount of material, temperature, luminous intensity, and electric currents. These are the SI system, the unit quantities. Now, these unit quantities had unit names and then unit symbols. The unit symbols are derived actually from the unit name. Now, for length was represented with meter, and then the symbol with small letter m. That you can see from as unit symbol. Then amount of material is represented with mole with symbol MOL in small letter. Then temperature, Kelvin, K. Then luminous intensity, candela, CD. And the electrical current, ampere, with capital letter A. Now, you should understand at this point very clearly as students. Now, you should be acquainted with these SI units so that whenever you are presenting results, you should be able to present results accurately. In the SI unit system, prefixes are used to indicate decimal fractions and multiple of various units. Now, very, very important, you should understand that in the SI unit, prefix from the metric system are used to indicate decimal fractions or multiples of various units. Now, that you can see. Now, other prefixes can also be added to the SI unit to form other units. For instance, where we have said mass, the unit of mass should be kilogram. Now, prefix like milli, micro can be used to form other units. Now, smaller quantities of mass can be measured in milligram. Also, smaller quantities of gram can be measured in microgram. The same thing is applicable when you talk about volume. Volume is measured in liter, but smaller volumes can actually be measured by the use of the prefix of the metric system, like milliliter, microliter, and what have you. It can be used. That is applicable to other SI units where prefixes are introduced to define or to create other units of measurements. Some measurements are made directly from the laboratory, while some are gotten through calculations. For instance, density might not be measured directly. It can be derived from other measurable quantities like mass and volume, because density is mass over volume. And there are many others. And when we say unit, we're not saying, when we say measurement and unit, we're not just saying a unit can just be a symbol. It can be one, it can be two, it depends on the dimensional analysis of that calculation. Particularly when we are talking about derived units. Derived units are most times of multiple units, or rather multiple symbols. Multiple symbols. Now, for instance, talking about the units of density, being that density is mass over volume. Now, definitely, when you derive that the unit of mass is kilogram, and then we say the unit of volume should be cubic meters, then the unit of density should be kilogram over MQ. Kilogram over cubic meter. Now, That will be the unit of density. Here in that unit, you have kilogram from mass, then you have cubic meter from that of volume. So when you are taking measurement of speed or acceleration, now speed is distance over time. So distance is measured with meter, and then time is measured with second. So that is why speed, the unit of speed, will always be meter over time. So you should take note of that. I would like to lay emphasis on measurement of mass and volume using the metric system, the prefix from the metric system. Now, mass, we have all agreed that the unit of mass by the SI unit system is kilogram. But some among all the symbols or the units of the SI unit system, you discover that only the unit of mass is carrying a prefix, which is kilo, a prefix. Now, kilogram. Now, somehow, scientists are more comfortable using gram, being that gram, there's no prefix. So when you have quantities that are higher than grams, then you can comfortably employ the prefix kilo for it to be kilogram. And then if you have measurements that are less than grams, you there have units like milligram. It can be microgram. It's very, very important to take note of that. So these are also units of representing measurement of mass, which is derived from the metric system. Now, when we talk about volume, the SI unit system, volume is represented with the unit cubic centimeter. Now, in the cubic centimeter is MQ. Now, the reason that came into play is very important to note. Scientists were making measurements of volume from objects or containers that has height, it has breadth, and it has length. So that kind of containers or device used in measuring volume, to calculate the volume must always be the length times the breadth times the height. And when you do that, you discover that you will end up having the cubic meter. And that is why cubic meter is used to represent volume. But today scientists are more confident using liter to represent volume measurements. For smaller quantities, measurement of volume now is also represented with CMQ. This is how they arrive at cubic centimeters. That CMQ is actually pronounced cubic centimeters. Now, this cubic centimeter is equivalent to the volume in milliliters, while liter, which is used to represent volume in place of cubic meters, is equivalent to which is what we call the DMQ. Now, a very, very important scientists are no longer using, or somehow gradually phasing out the use of DMQ and CMQ. In place of DMQ, a liter is used, while in place of CMQ, we have milliliter being used. Now, which is ml, while liter is represented with L. Liter replace the use of cubic meter, while ml, which is milliliter, replaces the use of CMQ. We have earlier agreed that from the metric system of measurement, now we understand that 1,000 grams are equal to 1 kilogram. It means the relationship between kilogram and gram is 1,000. 1,000 grams equals 1 kilogram. Now let's make an attempt to convert from kilogram to gram. From this, that this is 10 grams. 10 grams. Now, we want to convert, this is 10 kilogram. We want to convert from kilogram to gram. Kilogram to gram. Now, to convert from kilogram to gram, what we need to do, we need to look at the relationship between kilogram and gram. We have agreed that now 1,000 gram equals 1 kilogram. In the same way, 1,000 milligram equals 1 gram. This is the relationship. The relationship here is 1,000 into 1. Now, understanding that is the relationship, we want to do some conversion. We're converting first of all from kilogram to gram. Now, whenever you're converting from a greater quantity to a lesser quantity, what you should do is you should make sure that the relationship that you have should be used to multiply the value you are converting from. Now you understand that kg is greater unit than gram. So we are going from kg to gram, that is kilogram to gram. We have to do or prepare our conversion expression as such that the relationship, which is the 1,000, is multiplied to the value we are converting from. And then you should also arrange the conversion expression as such that the unit you are converting from is cancelled out and the unit you are converting to is sustained. So the unit you are converting to must always be at the top, while the unit you are converting from must be at the down to cancel out the unit on the value you are converting from. It's very, very important. So you should understand what is conversion expression, also what is conversion factor. It's very, very important here. Now, we are taking conversion of kilogram to gram to start with. to start with. Now, after we have done that, we will still go to grams to kilogram. Now let's look. Or 10 kg multiply by 1000 grams divided by 1 gram. The kilogram and kilogram here will cancel out, and then gram is maintained, then which will be 10 times 1000 grams equals to 10,000 grams. Now we arrive at 10,000 grams. 10,000 grams. Now let's also try to convert from the lesser quantity to a greater quantity. If we are measuring from a lesser quantity to a greater quantity, which is gram, is a lesser quantity compared to kilogram. Now, as we are moving from the lesser quantity to a greater quantity, what we do, the relationship will be used to divide the value you are converting. In this case, the value we are converting once again is 10. Now, for the fact that gram is less than kilogram, what we do, we inverse the conversion factor as obtained here, and we say 1 over 1000. That is your conversion factor. Now, in this conversion expression, 10 gram times 1 kilogram over 1000 grams, grams and grams will cancel out. We'll now just have 10 times 1 kilogram over 1000, which will give us 0.01 kilogram. That is the conversion. So you can use this to carry out any conversion as far as the relationship is known, as far as you've been able to get the conversion factor, which can be gotten from the table, which shows the relationship between different units. That can be used to convert from one unit to the other. Now, let's go to volume. Conversion of units relating to volumes. Now, we've said the relationship between liter and milliliter is 1000, and that 1000 milliliters is equal to 1 liter. Now, in that case, we can also go and convert from liter to milliliter, also milliliter to liter. Let's first take conversion from liters to milliliter. Now, take for instance, we have 10 liters. Can we convert from 10 liters to milliliters? How many milliliters do we have in 10 liters? We look at the conversion factor. The conversion factor is 1 liter is equal to 1000 milliliter. Now it means that the relationship is 1000. Being that liter is greater and milliliter is lesser, we're converting from the greater to the lesser. What we do, the relationship will be used to multiply the value we are converting. Now, look at it. This is 10 liters. So 10 liters times 1000 ml over 1 liter. The liter here and the liter here will cancel out, and we will now have 10 times 1000 ml will now give us 10,000 ml. The same way we can go conversion from milliliter to liters. Now, this time we are going from the lesser to the greater quantity. Hence, what we do, the value, the relationship will be used to divide the value you are converting. So here now, in this conversion from milliliter to liter, now here 10 milliliter times 1 liter over 1000 milliliter. Now milliliter and milliliter will cancel out. We'll now have 10 times 1 liter over 1000, which will give us 0.01 liter. That is conversion for liters. And you can use this to convert, manipulate from one unit to the other in volume measurements. It can be microliters, it can be milliliters, microliters to milliliters, microliters to liters. It can be liters to kiloliters. Once you know the relationship, you get the conversion factor, then you are good to go. Serial conversion is the conversion that requires conversion through an intermediate unit before the target unit. That is serial conversion. Now this time we are taking mass now from milligrams to gram to kilogram. Look at the relationship. 1000 milligrams equals to 1 gram. 1000 gram equals to 1 kilogram. You have to look at the unit conversion expression. Now, look at it. Milligram times gram over milligram times kilogram over grams equals to grams. As you look at it, milligram will cancel milligrams, and then grams will cancel grams, and what you have there is just grams. Take time to study this. Let's try convert 100 milligrams to kilogram. Now to convert 100 milligrams to kilogram, there is an intermediate unit which is grams. So you must have two conversion factors. Now the first conversion factor is gram to milligram. Now gram to milligram, you discover that the conversion factor is 1 over 1000. Then kilogram to gram is also 1 over 1000. Now those two conversion factors are joined together. Look at it. There we now have the multiplication. 100 milligram times 1 gram times, over 1000 milligram times 1 kilogram over 1000 grams. That equals to 0.001 kilogram. That's the answer. Let's consider three examples. First is kilometer to miles. Converting 10 kilometers to mile, conversion factor between kilometer and mile is 0.62 over 1. Conversion expression will now be 10 kilometers times 0.62 miles over 1 kilometer is equal to 6.2 miles. Let's take second example. Now we are converting from 10 square centimeter to square inch. Now conversion factor between these units is 0.155 over 1. Conversion expression will now be 10 square centimeter times 0.155 square inch over 1 square centimeter. Now the result will now be 1.6 square inch. When the similar unit cancel out, we just have inch. You can look at the third example. Look at the conversion factor, look at the conversion expression, and then look at the answers and how the unit cancel out again. And please do well to practice other activities on the table. Following this example, is believed that you have a good day. Thank you very much.